welcome to episode number 2 of Let's Make It. And this week we're going to focus on the Arduino, as you mentioned last week. And if you don't remember that, this is an Arduino. This is an Arduino Uno. And we're going to talk about the Arduino a little bit today, a little bit about what is the Arduino. And we're actually going to write some programs. We're going to do 2.5, basically. We're going to take a program and modify it just to give some demonstration of what it can do. So let's first talk about the Arduino. The Arduino is a development board. I call it a development board because it's designed to quickly do rapid prototyping, rapid development. Very popular in the maker community for doing things of many things, really. I've seen it used so many different ways because it's very flexible. I've seen it used in robots. I've seen it used in toys, particularly stuffed animals, so they do different things depending on what you do to them. I've seen them used, I can't even think of where I've seen them used. They're used all over the place in the maker community, especially. That's very big. And it was really a maker who kind of designed the Arduino. So let's talk a little about what the Arduino is, or what makes an Arduino. It runs an Amtel chip, which is a fairly popular chip for doing microprocessing. And it's either an Amtel or a PIC or something like that. Typically, it's pretty common. Nothing special about the chip itself. Where the special thing comes in is the design of the board. You'll see on this board, actually, let me go to a different camera here. Let's go over to this camera. And this is an Arduino, and I got it plugged in right here, but here's the one I had in my hand. You'll see on the Arduino itself that you have the chip, and then you have these raised areas, and those are where you can quickly plug in a development board to development on the Arduino. So it's more than just the chip. It's more of a development environment. Now, on top of the chip runs the software from Arduino, which is basically a C programming language, which is what the Amtel is the development kit runs in. But what they've done is they've added a nice interactive development environment, or an IDE. And they've also added a lot of libraries that make using the chip very, very easy. So this all put together makes it an Arduino. Now, the Arduino is an open source, so you can download the software, the source code of the software. You can download the design of the PC boards and do anything you want with them. I mean, they're open. It truly is an open source hardware and open source software. So that's part of the Arduino ecosystem as well, and it's very popular. In fact, there are many companies other than Arduino that make these boards now. So that's basically what makes an Arduino an Arduino. It's not the chip that's on it, it's what makes the chip work in the development environment that's been created for the Arduino users in the Arduino community. And it's been around, I think, from about 2005, if I remember correctly when I looked it up. 2006 maybe, I can't remember one of those two, but it's been around for a while. So we're going to do most of our development on this Arduino Uno. Now we do have the newer Arduino board, and it does some keyboard emulation, but at least for these first few, we're going to be using this Arduino Uno. You can pick it up online. I think I saw it on Amazon for like $21 the other day. I'll go look here in a second and we'll take a look at it. Now, to get some information about the Arduino, let's go talk about that a little bit, and let me switch over to my computer. So this is the Arduino website. The website is arduino.cc. It is not arduino.com. Sorry, that's confusing. I've gone there so many times, and if you go to arduino.com, I think they sell t-shirts or something like that, if I remember correctly. So if you go to arduino.cc, you can see right here where you can buy. You can download the software, and let's go look at that real quick. So here's the Arduino software and licensing agreement, and they have development environment for Windows, Mac, and Linux. And then you also download the source for the environment as well. What I'm going to be showing you on is actually on a Mac. The Windows software, from my understanding, sometimes is a little tricky to install. The Mac just installs and works, which is what we use mainly here. On the site, you also have some information on getting started. Here's the install guides for installing it, the environment, the libraries, and also talks about the Arduinos over here. Now, what we are getting is the Leonardo, which is we just got it, I think, today, as a matter of fact, and we haven't really played with it a whole lot. But its big attraction to us is its ability to emulate a user interface device like a keyboard or a mouse. So that's where our interest is on that. If you come over to the learning, there's plenty of examples out here. You can learn about all the basics, and we're actually going to look at the bare minimum and the blink today, and we're going to modify the blink and to demonstrate a little bit what is available inside of the Arduino as far as making changes in the code. So that's where the two we're going to cover today. Next week we're going to talk about buttons a little bit and some other options there as well. So you can see the examples are right here. You can come out and get them, and it's pretty easy to learn from that. Plus, they also have other reference information about the actual language itself. And basically, we'll get through this a little bit later, there's really only two things that are required in the C language for the Arduino to work. And this is something that the Arduino itself requires, not necessarily the C language. It just is the code that runs on top or underneath of your code that is your link between the chip and the Arduino. And you can also see they have some product information. You'll find if you go and you look, there's a lot more products than just from Arduino themselves. I have so far used quite a bit of Arduino hardware from them, and they're great. The other stuff that I've gotten that it's not from Arduino has also worked great, with the exception of maybe one LCD shield, and that's maybe could be me. That's the problem, not necessarily the shield itself. But here you can see all different size Arduinos. They get down to these tiny little mini ones. Here's a little USB one. They have shields, like I talked about before, that plug on top that control motors. And here's a wireless and an SD shield. So here's a Wi-Fi shield. You can keep adding all these different shields. The thing you have to be careful of, sometimes the shields will use the same pins. So this Arduino, I think, is 16 pins that are I/O pins. So as long as they're not using the same ones for the different shields, they should work fine together as well. So you just gotta be careful about what pins are being used. Here's a prototype shield. So this is a quick overview of the Arduino itself, and I do recommend you go to arduino.cc and just kind of look through the site. It's a great place to get some reference as to what the Arduino can do, and you can very quickly learn the language by going through their examples. So first thing we're going to do, let's look at Amazon while I'm here. Let's look at price for an Arduino. Oh, I did look it up. Here's the Arduino Uno that we're working with. You can find it. Here's Amazon, $21.95. And I think I saw one down here that were less expensive. I don't know what the differences are. They look like the same to me. I just always cautious when I see a difference in price of, on a $20 product, $6. Something to consider. But just go look to Amazon and just type in top Arduino, and we're using the Uno. You can leave it off, but if you're looking for the actual board, and you put in Uno or Leonardo, something like that. Because if you just put in Arduino, you get all kinds of stuff. In addition to the Arduino main board, you get all the shields and everything as well. All right, so let's hop over, and we're going to start with some really basic code. This is their bare minimum. You can see right here, so this actually came from, if you go in the Arduino and you go to File, Examples, Basics, here's the bare minimum. That's what we're going to look at right now. So I said before, there's two functions that are required to exist for the Arduino. The first one is setup, and if you're not familiar with C, we're going to go through it here a little bit. Void basically means that this function does not return any information. The setup is the name of the function, and there are no parameters you're passing it. So this is the function declaration right here. Everything in these two squiggly marks, or left bracket, right bracket, whatever you want to call them, is the code that goes into that subroutine. So what happens when the Arduino boots up? The first thing it does is it runs the setup routine. So in this routine, this is where we're going to put settings for setting up what pins are in, what pins are out, what pins do what, our constants, any values like that will all be set up in this section. It's only called one time, and it's only called during the setup itself. The other function that is required is called loop. And basically what the Arduino does is he keeps calling loop, 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 loop as long as it is on, it's going to continually call loop. So again, we're not going to return any information, and we're not passing any information, and the same squiggly marks and the code goes in here. So it will forever sit here and go through this loop. So what I'm going to do now is I'm going to plug in the Arduino into my laptop that we have. I'm going to go back to the Arduino. All right, so now we're at the Arduino, and I'm going to plug it in. You see right now there's no lights on it. All right, and I plugged it in, and you see it does nothing. It basically has a power light on and a single light, which is actually pin 13. Most of these development boards have an LED on pin 13, which is a great way to learn. You don't got to plug in any LEDs. It's already right there. So now we're going to go back over to the laptop, and to install this, first I do a check or verify. So I run verify, and I didn't get any errors. So at that point, what I can do is upload it, and it's finished uploading. Now I'm going to go back over to the Arduino. I'm going to upload it again, and you can see what it did. Nothing really fancy, but here's the Arduino, and I'm going to upload. So there's upload. You see it blink a few lights, transmit and receive, and it's back to where it was, because we didn't tell it to do anything. At this point, it's just sitting there looping through, doing nothing. So it's just going to look, kind of pretty sitting here, and no lights blinking. So what we're going to do now is we're going to go back over and we're going to load one of their other samples. It's called Blink. So let's go ahead and we're going to close down bare minimum, and I'm going to go to Arduino, or no, I already loaded right here. There it is, Blink. So what this one does, and at the very top, we're going to go through this from the top to bottom. These brackets, the slash and the star and the slash, anything between here is going to call it a comment. So basically the compiler ignores all this information between the slash and the star. If you have two slashes, it'll ignore anything on that line to the very end. So first here we says it's called blink, and it says it turns on LED for 1 second and then off for 1 second repeatedly. So pin 13 has an LED connected, most Arduino boards, like I said before, and in our board that is the case. So we're going to define LED as pin 13. So right now we're setting an integer called LED, and it's going to be equal to 13. Move on down, we get to the setup routine. The setup routine runs one time, and what it's going to do is it's going to say the pin mode for LED, which was set to 13 right here, is going to be an output pin, which means anything that we do with this pin is only for output, ignore all input. So that's the only initialization that we need to do. So after it runs through the setup, it's going to do the loop. Well, the loop, it says digital write, because we set the pin mode to output. For pin 13, because it's LEDs equal to 13, to high. That turns the LED on. Then we do a delay for 1,000 milliseconds, which equals 1 second. Everything we do in the Arduino for delays is in milliseconds. 1,000 milliseconds to a second. Then we're going to do digital write, and we're going to turn the LED back off again, and we're going to wait for 1 second. So let me verify this. It compiled, no problem. Okay, so before I upload it, I'm going to switch back to the Arduino, and you can watch what it does. So we're at the Arduino, and I'm clicking the button to upload. You see it loading the program, and now you see the LED is blinking. On for 1 second, off for 1 second. On for 1 second, off for 1 second. And it'll do this for as long as it has power, because that's all the loop has told it to do. Now what I want to do is I want to modify this loop to show you how easy it is to modify the code and to upload it. And all I'm going to do is make the LED blink 3 times, wait for 1 second, blink 3 times, and wait for 1 second. So let's hop back over to the to the laptop. And here we have the code. And I still want to wait 1 second between my blinks. But what I would like to do is make the delay a lot shorter. So I'm going to change to the delay. Hold on 1 second, let me get back out of this. Let me reload that example. I'm going to change the delay to 100 milliseconds. So let's first verify and upload this, and we'll see what we see different right now. So here's the Arduino, and it's been loaded. And one thing you'll notice is it's blinking really fast. It's not staying on for 1 second and going off for 1 second. It's blinking and staying on for 100 milliseconds and then waiting a second to come back on. So that's the first change to the program we need to make. So now what we want to do is we want to copy all of this and we're going to basically put in at this point another delay of 100 milliseconds. And then we are going to put in again another blink. And rather than type it all in again, I'm just going to copy this again. And we're going to put another one in. So what we are doing now is in the very beginning, we are turning on the LED for 100 milliseconds, turning it off for 100 milliseconds, turning it on for 100 milliseconds, turning it off, turning it on, turning it off. Now we actually don't need this last one right here because we already have a delay after it. So now let's go to the Arduino. First, let's check it, verify it. No problem. So now before I upload it, let me switch back over to the Arduino. And here comes the upload. So now what's it doing? So you see 3 real quick blinks and a 1 second pause. That's how easy it is to make a change to the Arduino. Now, one thing I did not really go over is some of the punctuation in the code itself. And this is something you're going to learn pretty quickly. But it is basically a C language. And with C, every line has to end with a semicolon. So that's very important. In fact, if you do not put a semicolon, if I run this and do a verify, you can see it expects a semicolon. So it's just something to kind of remember at the end of every line. Like a period in English, we need a semicolon at the end of every line. So let me add that back in, and we'll check it again. And we're good this time. So that's an important thing to remember. The other thing that I want to mention here, and this is mainly for people that have done some development, is, and I don't know why they did this, but they call these sketches. They, to me, are programs. I would call this a program or source code, but they call them a sketch. So if you see the word sketch, basically what it's doing is referring to the program. Even if you go into a sketchbook, you'll see things that I've saved, which I haven't saved anything on here. But these are example sketches. So you can go through and look at the examples. It's just another word for the word program. It's just confusing. It confused me for a little bit. When I first got it, I was like, well, where's the program? I want a sketch. I want to write a program. And then I figured out the sketch was a program, and it all makes sense now. So that was a quick overview of our first overview of the Arduino. And I do recommend, if you're going to get in this, the Arduinos are not expensive. They run off a USB, plugged into your computer, and the software, everything else is free. It's a great learning tool, and it's actually great for kids. I know a couple kids now that are wanting to learn programming, and they're actually doing it on the Arduino because it was inexpensive and they can do neat things with it. I think one of them got it because he saw you make robots with it and make cars move, which we'll talk about some motor control in the future, but not necessarily the robots. But if you go out and look for Arduino, there's plenty of Arduino projects that are robots, and we're looking forward through our stuff a little bit ago where I'm going to be talking about some other things you can do, temperature sensing, stuff like that as well. And one of our projects that we're working on is remote controlling notifications based on a central location using over wireless using Zigbee. And it's something that's kind of a missing need in some of the applications that we do out in the real world as far as doing videos. So we'll go into more explanation of it later and how we're going to use it, but it has other things it can be used for. And then part of our design is to make it more of a utility, like a utility knife, it's like I like to call it, because it does more than just what it was originally thought up to do. and it's all done using something like the Arduino. Actually, it's the same chip as the Arduino, and using little Zigbee add-ons, which I saw. I think I had one of those last week when I did the video, the Zigbee. So it should be able to communicate up to 1,000 yards, I think is what the Zigbee with the external antenna on it says. So it's pretty robust. And and Zigbee itself is a robust protocol. And if one of the units was within 500 yards and the other one was within 800 yards of it, but too far away from the main unit, they'll talk to each other and pass it around. It's pretty interesting protocol. And maybe we'll get into talking some Zigbee at some point as well. It's still a learning process for us. It seems to be very simple and almost one of those things where it's too simple. So next week we're going to talk about buttons, and we're going to use the Arduino, get a breadboard, and we're going to talk about how to use a button to take input into the Arduino. And then I think beyond that, I think I'm going to do a temperature sensor next, and maybe even do an accelerometer so you can tell what angle the Zigbee or the unit is facing. Like, is it upside down? Is it turning? And talk about some of the X, Y, Z coordinate systems that you can bring in. So we have a lot more stuff planned. We want to talk about LCDs, outputs, so we can put words out, things like that as well. So check us again next week. If you are not subscribed to us on YouTube, please hit subscribe. If you're watching us right now and using some form of podcasting like iTunes or something like that, please subscribe so you get the latest updates as they come out. These come out like once a week. Right now they're coming out on Wednesday nights. So if you're also watching live, please join the chat room. I love feedback. I was only one person in the chat room today, and I'm not sure. I don't know who it is really, but not really saying much either. So I love the feedback. Our other shows thrive off the feedback that's from the chat room. So we really enjoy the input from that as well. If you go to our show page at techzen.tv /make it work, you can also see other contact information. We have Twitters you can get on. We have Google Plus community you can join, and you can also call and leave us a voicemail at Google Voice. We have a Google Voice number. Nobody ever answers the phone, but you leave a message, and we get your message that way. So I hope this was enjoyable to you, and if so, please come back next week and watch the next one. And again, all feedback is greatly appreciated. Thank you.